Hi everyone, we have question 75 from 6th chapter of the Beer&Johnston textbook, and we need to determine the force in member BD and the component of the reaction at point C. So obviously we are in equilibrium, and we're going to start with the free body diagram of the member ABC. So let's draw the free body diagram for ABC. So what we're going to have in here is that if I look at point C, we'll see that we have a pin, which means we have both x and y components, cx, cy. And if we look at the member BD in here, we'll see that we have a two-force member, which we have a member that there are only two forces at two ends of this member. So the force will be along the line that connects B to D. So we can consider F BD in here regarding the direction. We can just assume something for now, and if we get the negative sign at the end, it shows that our assumption wasn't correct. And we have the 160 pounds force applying at the end of this member. So looking at this, we have three different unknowns, which means we need three different equations to solve this. And the way we're going to solve this is that we are in equilibrium. We have sum of all forces equals 0, which we are in 2D. So we're going to have one equation for x, one for y, so 2 in here. And we're going to have the same thing for moment. And that way we can find up to 3 unknowns in this question. So let's start with the moment equation. And since we have the most unknown at point C, we're going to start with C. That way we cancel cx and cy. We're going to have the moment of FBD. And if we resolve FBD into two components of x and y, we can see only the y component is going to make moment. The other one is going to pass through point C, which means no moment. And the question is how we're going to find the y component. If we call this angle here alpha, that alpha would be easy to find if we look at this right triangle in here. We have one side 10, the other 24 inches. So based on Pythagorean theorem, we can find the hypotenuse. So let's see how we can find that. The square root of, so we're gonna have the square root of 10 squared plus 24 squared. So that's gonna give us 26. So our hypotenuse in here is actually 26. Now the angle that we were talking about is that one, alpha, and the moment of y component about C is in this direction, so it's a counterclockwise, it's a clockwise moment, so negative FBD times sine of alpha, which was gonna be the opposite over hypotenuse 26, and that's our force. The distance would be the vertical distance from C to the line of action, which is what we have in here. And if we look at this, we'll see that it will be 8 plus 8, or 16. So that's moment of FBD, and the last one is the moment of 160. This is going to be in this direction, so it's counterclockwise, positive 160, and the distance would be the length, or 16 plus 14, what we have from here to here. That's going to be 30 equals 0, and we can find our FBD from this part, which is the first unknown that we can figure out in here. So it's gonna be 160 times 30 times 26 divided by 10 times 16. Basically, I'm bringing FBD on the other side. And as we can see, the direction is correct because we don't get any negative answer in here. And actually, these two are canceling each other out. So let's calculate this. 160 times 30 times 26 divided by 160. That's going to be 780 pounds. But it's not over. We have to show that if the member PD is in tension or compression. So the force that I'm showing in here in this direction is the force from the member to the joint. But we are interested in the member, which based on Newton's law has to be in the opposite direction. So this is the member BD, which means it's in tension. So that's how we specify if the member is in tension or compression. So T for tension and C for compression. So now it's pretty easy. We have two more equations, Fx, Fy. We can find the other unknowns. We have Cx plus FBD this time cosine of alpha, which is going to be this time adjacent 24 over 26 equals 0, or our Cx would be minus 780 times 24 divided by 26. Let's see what we're getting here. So 780 times 24 divided by 26 is going to give us 720 pounds. And we have a negative sign in here that shows that Cx is actually in this direction. So our assumption was incorrect. And last one, sum of all forces in y direction. So we're going to have the y component of FBD, which was 780 times what we had in here, 10 over 26. We had the same thing for moment equation, 10 over 26. We have the minus 160 pounds, and we have Cy, and that's pretty much all the forces in y direction. So Cy would be 160 minus 780 times 10 divided by 26. So 160 minus 7,800 divided by 26. That's going to be minus 140 pounds. And again, one negative sign that shows that the direction was actually downward and our assumption was not correct. So that's the final answer for this question. Hope everything was clear. We're covering 3 different textbooks in this channel. Feel free to check out the playlist and let me know if you have any specific problem that you want me to cover. You guys take care. I'll see you in the next one.